Hello everyone and welcome back. Today we are going to discuss the wonderful world of pointers. And prior to watching this video, you should have read the chapter on pointers in the textbook. What I have here is our view of memory that we've used earlier in the semester. What I want to focus on is this area right up here, up towards the top. I have some gray areas, and here's the purple areas, some light orange, and some bright orange. Pointers are always pointing to memory addresses. So a pointer will always point to an address. Pointers are stored in memory also, so they have an address. This int pointer 1 has an address of 312. Here's int pointer 2, its address is 369. The value in int pointer 1 is 200. That is a memory address to an integer. Int pointer 2, likewise, is a memory address to a pointer. If we look here, this is pointing to memory address 200. If we glance over here to the right, int 1 at memory address 200 has the value 16 in it. So int pointer 1 is actually pointing to this memory address, and the contents of that memory address is 16. Likewise, int pointer 2 is pointing to memory address 248, and 248 is the variable int2, and the contents of int2 is 32. Pointers can also point to arrays. We will get into arrays and pointers in the next video. So, to summarize, pointers are always pointing to memory addresses. You cannot have a double pointer pointing to an integer. If I had a double somewhere, let's say length was double right here, if length was a double like that and its address was 123, we could not have address 123 here. This does not work. An integer pointer which points to an int cannot then point to a double. I'm going to back out of my changes here, and we'll look at some code now. So I've written some code to further investigate pointers. What I've declared here is 3 integers. I've also declared 2 pointers. The way you declare pointers to a type is you specify the type. So I want to point to integers, and then I hit the asterisk key. So int star is an integer pointer to an integer. So in this case I have int pointer 1, which is an integer pointer, and it always points to a memory address. Here I prefix int 1 with the ampersand. What that means is get the address of int 1 and store it in int pointer 1. So I'm initializing int pointer 1 to the address of int 1. An ampersand in front of any variable will always return its address. Okay? Is the address of wherever int 1 is in memory. And likewise for int pointer 2. Here I'm just pointing things out, printing things out, and we will walk through this code. Okay, I've set some breakpoints. Now I'm going to run my program. So as we can see, we are at line 37. int1 has the value of 16, int2 has the value of 32, and int3 has the value of 128. Remember, the ampersand in front of any variable returns an address. This address is hex, so don't worry about that right now, but int1 points to this memory address, int2 points to this memory address, and int3 points to this memory address. We can see that the address of int pointer 1 is currently at 18FE44. Int pointer 1 is pointing to an address. We can see that right here from line 18, int pointer 1 points to an address, and it better be the address of int 1. We can verify that by looking at the address here and verifying that it is the same address we have right here. An asterisk in front of a pointer variable is called dereferencing, and that gives us the value at this address. So star in pointer 1 is the value at the location in pointer 1 points to. Okay, so let's discuss that again. In pointer 1 is an address to memory. Furthermore, it's an address to an integer. That integer is int1 right here, which has a value of 16. The address of int1 is 0018FE68, which we can verify is the same value here, 0018FE68. And when we dereference a pointer, we're getting the value at which the pointer points. So star int pointer 1 is pointing to the value of int1, 16. Now if we look over at our code, we can say I am setting int pointer 1 to now point to the address of int2. So let's continue the code here and verify. I'm going to continue to the next breakpoint. The address of int pointer 1 has not changed, 0018FE44, but what int pointer 1 is pointing to has changed. It's now pointing to int2, as we can verify by this address here, 0018FE5C, which is this value, 0018FE5C, which is the value of int pointer 2, which is now 32. Now, if we look at our code here, we're saying int4 is equal to the value of what I'm pointing to at int pointer 1 plus the value of what I'm pointing to at int pointer 2. Remember, we changed what int pointer 1 points to, now int 2. So int 4 should be the value of what int pointer 1 points to, which is int 2, plus the value of what int pointer 2 points to, which is int 2, for the sum of 64. Let's see. Int 4, what int pointer 1 is pointing to plus what int pointer 2 is pointing to, and that is indeed 64. So what happens when we add 1 to int pointer 1? Remember, int pointer 1 points to an address in memory. So what are we going to get in this case? So let's press F5 right now and see what happens. So if we look at this carefully, we see we added 1 to int pointer 1. Int pointer 1 now points to the memory address 18FE60. So what happened here? We had previously had the address in int1 pointer, 0018FE5C. Int pointer was incremented by 1, but an integer requires 4 locations in memory. And 4 locations in memory from 0018FE5C is 0018FE60. Remember, we're counting in hex here. So, what int1 was pointing to, which previously was int2, which has this address right here, is now pointing to an address that is 4 locations away. And what is in that memory address? Garbage is in that memory address. So pointers can be very confusing, and you can get in a lot of trouble with pointers, although pointers are very powerful. To review, if we look back at our code, an integer pointer points to ints. Okay, this is a pointer to memory. A pointer is always pointing to a memory location. You specify a pointer by specifying the type of the pointer, which can only point to integers in this case. We put an asterisk. We specify the variable name. And what I'm doing here is I'm initializing what int pointer1 points to by specifying the ampersand, which always returns an address. So I'm specifying that int pointer1 is initialized to the address of int1. Then when we want to dereference, we put a star in front of the pointer, and that's telling us to take the contents of the memory address that int pointer1 is pointing to. We can add what int pointer1 is pointing to and int pointer2 is pointing to, and return it to be stored in an integer, because here we dereference in pointer1, here we dereference in pointer2. We add them together to give us an int. When we add 1 to an int pointer, we are actually going 4 memory locations away from the pointer. As we saw in this case, we are pointing to an uninitialized memory location. This concludes the video on pointers